Okay, so now we are going to look at mechanics. But before we start with the mechanics class, there is something that we need to know, a prerequisite that we need to understand before we start with the mechanics class. So I would introduce you to a bit of trigonometry. I am not going to delve into details. I will just talk about the very bits that we will need for the mechanics, and we would also look at the sine rule and the cosine rule. Then we can start with the mechanics class. So when we talk of trigonometry, it just deals with the study of the right angle triangle. So if I have a right angle triangle like this, so this is a right angle triangle. Now you know it's a right angle triangle because there is a 90-degree over here. Okay, so a right angle triangle is a triangle where you have one of the angles to be 90 degree. So if I have this, now I can take one of the angles over here. So let's say I take this angle and call this angle over here theta. So if I call this angle over here theta, I can name the sides of this right angle triangle. So I can have this part over here has the hypotenuse. I can have this side over here as the adjacent, and I can have this side over here as the opposite. Okay, so now this is how to name a right angle triangle. So now when you take a look at this triangle over here, the longest side is this. So the longest side is always the hypotenuse. Then the side that is next to our angle. So you can see that with this side over here, this line over here is next to our angle, which is the theta. So the angle under consideration is theta. So this side is next to the angle. So therefore that side is the adjacent. And adjacent just means next to. Okay. Adjacent means next to. So this side is next to our angle. So that is the adjacent. And then you can see that this side over here is opposite to our angle. So that is the opposite. Now, if I had my triangle this way, and my angle under consideration maybe is somewhere over here, theta, then in that case, the hypotenuse will still remain the hypotenuse. Then this side will now become the opposite. Because now you realize that this side is now opposite to my angle. Then this side over here becomes the adjacent. So initially when I had the angle over here, this was the opposite, this is the adjacent. Now if I take my angle up here, now you can see that this side is rather next to my angle, so that becomes the adjacent. And this side is opposite to the angle under consideration. That is the opposite. Now when you take a look at trigonometry, now trig just deals with any of these two sides. Okay, so trigonometry deals with how the opposite relates with the adjacent, how the opposite relates with the hypotenuse, and how the adjacent relates with the hypotenuse. That is what we are going to do with trigonometry. And without wasting more time, I'm going to introduce the trig functions. That is the cos, um, the sine, and then the tan. Okay, so the trig functions, we have the cosine, which you cut it short as cos. Then we have the sine, which we write as this. That is the sine, not sin. Okay, the sine. Then we have the last one, that is the tangent. And the tangent is written as tan. Now, when you take a look at the first one, the cosine or the cos. Now, the cos relates the adjacent and the hypotenuse. So the cos is given as the adjacent over the hypotenuse. The adjacent over the hypotenuse. That is the definition for the cos. And the sine is given as the opposite over the hypotenuse. And the tan is given as the opposite over the adjacent. So now this is how to relate the sine, the cosine, and then the tan. So for example, if I have, let's say, a right angle triangle like this, and this side over here is maybe 4, and I have 5 over here, and maybe I have this to be x, and now I am asked to find the tan of x, the cos of x, and the sine of x. Now if I want to find the tan of x, now the tan of x is given as, so the tan is equal to the opposite over the adjacent. The cos is given as the adjacent over the hypotenuse, and the sine is given as the opposite over the adjacent. Now to recall this, you can use the SOHCAHTOA to recall this. Okay, so we know of this. That is the SOHCAHTOA. So the SOHCAHTOA. So the SOHCAHTOA starts with the sine. So the sine is equal to the opposite over the hypotenuse. That is the OH. So that is the SO. Then the K is the cos. So the cos is equal to the adjacent over the hypotenuse. Then the tan. That is the TOA. So opposite over adjacent, that is the TOA. So you can use this to recall these things over here. So when we start with the first one, now we have the tan of x is equal to, so now it is opposite over adjacent. So for my diagram over here, now my opposite is going to be the side. Now you can see that in the question, it has not been given. They didn't give us the opposite. So we have to use the Pythagoras theorem to solve for the opposite because this is a right angle triangle. So we need to use the Pythagoras theorem to solve for the opposite. Now from the Pythagoras theorem, if I have 5 squared, that is equal to, so 4 squared plus, now I can call this side over here maybe y. So then plus y squared. Then I solve for y, I get y is equal to the square root of 25 minus 16. So I have skipped most of the steps. I'm sure you can fill that in. So this is just a quick recap on trigonometry so that we can start with the mechanics class. So now 25 minus 16 is going to give me 9. So this is 9. And the square root of 9 is going to give me 3. So therefore, this over here is 3. So now the tan of x is given as the opposite. Now the opposite is 3 over the adjacent. The adjacent is 4. So that is the answer for the first one. And the second one, the cos of x. So the cos is the adjacent over the hypotenuse. So the adjacent is 4, the hypotenuse is 5. Then the final one, that is a sine. So the sine is given as the opposite over the hypotenuse. So the opposite over the hypotenuse. So now we've been able to do the cos, the tan, and the sine. Now, with this, we can also be asked to find for the angle. So now the x you see over there, is an angle. Okay, so we can be asked to find for x. Now to find for x, now we can use any of these trig functions, that is the tan, the cos, or the sine, to find for the x. So if I decide to use the tan to find for the x, now we have the tan of x is equal to 3 over 4. Then I can take the tan inverse of both sides. So I get x is equal to the tan inverse of 3 over 4. So now if you are looking for the angle, so if you're looking for the angle, then you have to use the inverse. So you take note of this. So because in this case I'm looking for the angle, that is why I am taking the tan inverse. So if I take the tan inverse of 3 over 4, now the result is going to be, now when you punch this on the calculator, so all you need to do on the calculator is just look for shift at the top left of the calculator, then you look for tan. So when you press on shift and tan, you're going to get a tan with a superscript -1. So now you punch that on the calculator, and this is going to give you 36. It is going to give you 36.87. So 87 degree. Okay, so degree. So that is going to be the angle X. Now, if you decide to use any of this to solve for it, to get the same thing. So for instance, if you want to use the cos, you still get the same answer. So with the cos, if you decide to use the cos, then now we have the cos of x as so it's 4/5. Now this is going to give me x is equal to the cos inverse of 4/5. And again, you take your calculator, you press on shift, and then you press on the cos. You're going to get a cos with a superscript -1. So now when you press on that and you put in this number over there, you're going to get the answer to be 36 point. So you get 36.87 degree, which is what we had for the tan. Now if you still want to use the sine, you still get the same thing. So with the sine of x, now this is equal to, with the sine of x, now it is 3/4, sorry, 3/5 rather, 3/5. Then we take the sine inverse of both sides. So I get x is equal to the sine inverse of 3/5. Then now x is equal to, so now when you do the sine inverse, you're going to get 36.87 degree. Okay, so now whether you use the sine, whether you use the cos, whether you use the tan, you still end up with the same answer. But with this particular case, I am going to stick more to the tan. That is what we are going to use more often with the mechanics. Okay, so you have 36.87 degree. Now let me introduce another angle over here. Let me introduce another angle over here. Maybe call this angle over here angle B. Angle B. I want you to solve for angle B. Okay, and tell me what angle B is going to be. So that is going to be a quick exercise to prove that you understand what we have just discussed.